Hi everyone, welcome back to the second video of Pygmy. In the earlier video you saw how to manage devices, how to manage the endpoints, and then how to register the device with the endpoints, and finally how to ingest data to the endpoint. In this video we are going to talk about the latency test. But before that, I would just like to remind you that we already have a device. If you remember, we had already created a device called Smart Washing Machine, which we already have in the system. And we have this device registered to all the three cloud endpoints, which is AWS IoT, the Azure IoT Hub, and the IBM Blomex Watson IoT platform. So what we are going to do next is take you to the latency test and show you how exactly it works. But before we do that, let us spend a few minutes on understanding what is latency and how the latency test works in Pygmy. So the latency of an IoT application is very important for the end users because IoT applications are meant to be responding in real time, and the user expects that as soon as the anomaly happens at the device end, the cloud should come to know of it and immediately take a corrective action. And this action could be in the form of a command that is sent to the device. For example, if the device gets heated up, then the cloud sends a command to shut it down. And the time elapsed between these two events is measured as the latency of the IoT application. And that is what Pygmy exactly measures. So now let us go and see how this exactly works. And the cloud endpoint that I have is IBM Blomex. I'm going to simulate the cloud application with a very simple node rate workflow. But right now, let us go back to the applications. To do the latency test, we have to choose an endpoint type. So here we choose the endpoint type IBM Watson IoTP. And as soon as I choose it, we have the endpoint instance, which is Watson IoT Platform 001. And we also have the device registered with this endpoint, which is Smart Washing Machine. And as this device was selected, you can see that a JSON was pre-generated for this device. Why Pygmy gives you an editor to modify the device JSON is because you exactly know what payload should I send so that this generates or creates an anomalous condition. So let us assume that on the cloud side, I have implemented the business logic that as soon as the water level goes below 20, I have to send a command to the device to shut down. In order to do that, I should modify this JSON and make the water level something below 20. So let me make it something like 19.5. What you see here is the editor of the node rate workflow. And what I've done is I've just had two nodes here. The first node is ingesting this data to the next node. And the second node sends an output type of device command. And to this device, this is the device of type washing machine, and the device ID is Smart Washing Machine, which is the same device through which we are ingesting this payload to the cloud. And we are sending a command, reboot command, and the JSON payload that will be sent to the device will come from the first node. So now when I start this test, the progress says that it is going to make an MQTT connection. Now it has made a connection and ingested the device payload, and now Pygmy is waiting to receive a command from the IoT endpoint. And you can see that the counter has started the moment the payload was ingested to the cloud endpoint. So now I go to the node rate workflow and I deploy this node. As soon as I deploy this workflow, node rate actually send a command back to the device saying that you need to reboot, and this is the JSON payload which was sent. Now, as soon as Pygmy received this command, it stopped counting the millisecond or incrementing the milliseconds, and then it reports that the total latency of the IoT endpoint is 19,163 milliseconds, and this is the command which was received by it, and this was the payload. If you want, you can just save the result like earlier. So I saved this result, and now I'm taken to the result screen, and now what it shows me is that the latency test was completed. This is the command that I received, and this was the total latency of the endpoint. In the next column, you see the JSON payload which was received by Pygmy. So now you get a very clear indication of what is the total latency of your cloud application. In case it doesn't meet the required SLAs, you need to modify or make changes on the cloud side, and then again come back to Pygmy and then make a second test. And so you should keep on iterating this till the time the latency of the cloud endpoint meets the agreed SLA. And this is how Pygmy would help you. So when you have gone through a cycle of tests, you would have 3, 4, 5, or maybe more results here. And if you want to report them into some reporting tool or into your Excel reports, then you should export the results, and Pygmy will generate a CSV file for you, which you can use further. So that was all about the latency test, and I hope you found this video useful. Thank you.